This next one doesn't have any numbers, but it has like variables for each of, like it's just calling mass variable M. It's calling amplitude variable A. It's calling the spring constant K. I like that because that means I don't need a calculator. All I have to do is manipulate the formula to get it. Now, in this one it says, in terms of the given quantities, what's the maximum speed? Well, I know that the maximum speed is going to be equal to, because if they're mentioning amplitude, I know that at the amplitude, my energy will all be potential energy, elastic potential energy. And I know that that value will equal the kinetic energy at its equilibrium position. So I know that the kinetic energy that's at the equilibrium position, I'll call it KE, is going to be equal to the elastic potential energy at the stretch. I don't know. I guess I'll call it S for stretched position. So at the equilibrium position, that's going to be where the maximum velocity is. But that value for energy will be the same as when it's fully stretched. Well, I know my formula for kinetic energy is going to be 1/2 mv squared. Now that's going to be the maximum velocity as long as the value for that amount of energy is equal to the energy when it's fully stretched. Now our formula for elastic potential energy is 1/2 k x squared. So x could be anything because it could be just a short distance away from the equilibrium position, but I want its maximum. And its maximum will be when it's at its full amplitude. So I'm going to be putting in for the x a squared. So that's a formula that's going to get me the maximum velocity. So you can see here that the halves can cancel out if I multiply through by 2. And I'm looking for the maximum velocity. So I just need to take the mass, bring it down there, and take the square root. So my mass, whoops, let me do it over to the right here because it doesn't work as well here. Whoops. So if I do it over to the left, over to the right, I'm going to get that Vmax is going to equal, oops, let me, somehow when I cancel things out, my halves were canceled out. So when I multiply through by 2, I get that. Solving for Vmax, I'm going to get K A squared over M. Now that would equal V squared, because if I bring the M down there, I get K A squared divided by M, and I want Vmax, not Vmax squared, so I'm going to take the square root of that. And now just putting in the values, and we'll have the answer for the maximum velocity. So that's going to equal K A, whoa, that's, I don't have to do that. There are no numbers to put in. They just gave me those, so that's my answer. So let me erase that because I'm already done. My answer is Vmax is square root of K A squared over M. Now, since A squared is a perfect square, if you want, you can take that out, and you can write it as Vmax. If I take out the A squared, I'm going to get equals A times the square root of K over M. Now, I do want to make one comment here about this problem. Let's say they asked me what the speed was when the amplitude was half of its mass, like when it was at half its amplitude. Well, when it's at half its amplitude, it's going to be half the amount of energy. So I know that the elastic potential energy is proportional to how far away it is from its equilibrium position. It's like if I throw a baseball up in the air and it goes up 30 feet in the air, whatever energy it has at 30 feet, I know that at 15 feet it's going to have half of that amount of energy. So I'm saying this because there is a retake, and it may not be this question. I may say, what's the amplitude, what's the velocity when we're at half the amplitude? That won't be the maximum velocity, but it will be half of this value. All right? Everyone follow that? So if I just took this and wrote over 2, then I'd have the answer for the velocity at half the amplitude. All right? Moving right through here.